In order to find the inverse, we're going to use the adjoint method. And we know that the inverse using the adjoint, involving the adjoint, is given by adjoint of A divided by the determinant of A. Okay? And the determinant of A is actually really easy because this is the lower triangular matrix A. So the determinant will be simply the product of the entries in the diagonal, because this is a triangular matrix. Alright, so it's going to be 2 times 1 times 2, which is going to be equal to 4, right? So that's easy. So the denominator here is equal to 4. Alright? So now we just need to find the adjoint, right? In order to use the adjoint, we actually have to find these entries, and then we need to find the transpose of these entries. All right, so and these are the cofactors, right? So find cofactors. Okay, cofactors of matrix A, the given matrix, right? So the cofactor of 1, 1, right, is equal to -1 to the power of 1 plus 1. You have to add up these subscripts, right, as powers of -1. Go to the other video if you're not sure how to do this. I explain how to find minors and cofactors, multiplied by the minor, and the minor is going to be the determinant of the entries excluded from the row number and the column number, so these 4, right? And the determinant of that is going to be 2 minus 0. I'm talking about the products of the diagonals here. 2 times 1 minus 0 times -3, right? So it's just 2. Right, so that's going to be positive, so it's just 2. The second one is, well, I'm not going to get into math. I'm not going to write this. So -1, 1 plus 2, the power of -1 is going to be 3, so that's going to be negative, right? -1 times, okay, so we're excluding row 1 and column 2, right? So it's going to be these entries, 0, 2, 0, -3. So as you can see, the products of these will be 0. So that's 0. Okay, C1, 3, row 1, column 3. Okay, so this is going to be 4th power of -1 is just 1, so we don't have to even write 1. We just have to find the minor, excluding row 1 and column 3. So, and again, this is 0, the product of these diagonals, right? So it's just 0. C1, well, 2 now. 2, 1. 2, 1. Let's see. Row 2, column 1. Right, row 2, column 1. Right, so it's going to be same deal as here, so we're going to have -1, right, multiplying. So excluding row 2, column 1, so these numbers. Since this is 0, we're going to just have -6, and that gives you +6. 2, 2. So that's going to be positive, right? -1 quadrupled is positive. So 2, 2, 2, row 2, column 2, excluding that. So we're dealing with 2, 2, 0, and 5. So that's going to be 4, right? Because the other one's 0, so it's just 4. C2, 3, row 2, column 3. To the 5th power, -1 is going to be negative 2, column 3. So excluding this and that, right? So, and these are all 0 multiplying, right? So it's just 0, 0. C3, 1. Row 3, column 1. So that's going to be positive. We don't have to write that. So dealing with these, because row 1 and row 3 and column 1 are excluded. So dealing with these numbers, so that's +9 minus 5. 9 minus 5, that's 4. All right, C3, 2. Row 3, column 2. Row 3, column 2. So that's -1 because of the odd power of -1 gives you negative. 3 and 2. So we're working with these 2 and -3. So that's just -6. It gives you +6. And the last one, 3, 3. That's going to be positive, right? We don't have to write that. And the minor is, the minor is going to be the determinant, right, of these 4, because they're excluded by the column and row numbers. So we were dealing with these 4. There's only this product that matters. This one's 0, right? So it's just 2. 2 subtracting 0 is 2. Right, so excellent. So we just found all the cofactors. Let's fill them in here. So we got 2, 0, 0, 6, 4, 0, 6, 4, 0, 4, 6, 2, 4, 6, 2. So the adjoint is going to be the transpose of this. And transpose means you keep the same diagonal. Well, actually, let me write it here. You keep the same diagonal numbers, and you just reflect the numbers to the sides of the diagonal with respect to this diagonal, right? So 0 comes instead of 6, 6 comes instead of 0. 0, 6, 0 comes here, 4 goes there, and 6 goes here, and 0 goes here instead, right? So that's the adjoint. Excellent. So the determinant is going to be this divided by the determinant, right? So so you can think of it as 1 over the determinant, which is 4, right? 4 is the determinant. So 1/4 multiplying by the adjoint. 2, 6, 4, 0, 4, 6, 0, 0, 2. Right? Simplifying that will give us the answer. 2 over 4 is 1/2. So this constant applies to all these entries. You should multiply them. That's what it means, right? 6 over 4 is 3, 2. 4, 4 is 1. 0, 1. 3, 2. 0, 0, 1/2. So there you go. You just found your inverse. So this is the inverse. I'm just circling the final answer, but this is the intermediate step, right, that we used. This is the inverse that you found of the original matrix using the adjoint method. And once again, if you're confused about this, some texts actually write it as 1 over the determinant of A multiplying the adjoint, because basically you're not gonna divide the matrix by the determinant, right? You're rather gonna multiply the 1 over determinant, which is 1/4, to the matrix, right? I just wrote it because it was simpler that way, but in reality, most texts, they just give you this formula for the inverse. All right, thanks for watching. Hope this was helpful, and see you in the next video.